There are 3 qualitative rules to predict the entropy change of the system. Rule number 1, or tool number 1. When the volume increases, the entropy of the system increases. Tool number 2. When the temperature increases, the entropy of the system increases. Tool number 3. When the number of particles increases, the entropy of the system increases. When I say particles, I mean molecules, atoms, ions, electrons, protons, neutrons. Let's look at some examples to see how do we apply these tools to tell whether the entropy change is greater than 0, smaller than 0, or equal to 0. This is our first example. We have 1 mole of reactant and we have 2 moles of product. According to rule or tool number 3, the entropy of the system should increase. Therefore, delta S is greater than 0. Let's look at another example. We have 2 moles of gas plus 1 mole of gas as reactants. So we have a total of 3 moles of reactants, and we produce 2 moles of liquid. From rule number 3, the number of particles decreases, so the entropy of the system should decrease. We can get the same trend from rule number 1. Because we have 3 moles of gas as the reactants, we have 2 moles of liquid as a product. We know that the gas occupies larger volume than the liquid or solid. So the volume also decreases. Therefore, delta S should be less than 0. Let's look at the third example. We have 1 mole of reactant. It produces 2 moles of cations and 1 mole of anions. According to rule number 3, the number of particles increases, so the entropy should increase. The entropy change should be greater than 0. Let's look at another problem. We have 11.2 grams of oxygen gas at 298 Kelvin and 1 bar pressure. Change to 11.2 grams of oxygen gas. The temperature is 298 Kelvin. It does not change. And the pressure decreased to 0.5 bar. And we also realize that the mass of the oxygen gas does not change. It seems when we go over the 3 rules, there's no rule that mentions the pressure effect. But we do know the ideal gas law. PV equal to nRT. Since the mass of oxygen gas does not change, so the moles should not change. And R is constant, it doesn't change. And the temperature remains the same. It doesn't change. So the pressure multiplied the volume should be equal to a constant. If the pressure decreases, the volume should increase. According to rule number 1, the entropy should increase. So delta S is greater than 0 according to rule number 1. Another example. 3.2 moles of oxygen gas at 298 Kelvin and 1 bar pressure. Change to 3.2 moles of oxygen gas. The total number of moles of oxygen gas does not change. And the temperature increases to 398 Kelvin, and the pressure remains the same. According to rule number 2, the entropy of the system increases. Therefore, delta S is larger than 0. This is from rule number 2. Okay, problem number 3. Which of the following states of carbon dioxide have the greatest entropy? Carbon dioxide solid, carbon dioxide liquid, and carbon dioxide gas. We know that carbon dioxide gas should have the largest volume. According to rule number 1, the entropy of the carbon dioxide gas should be the greatest. Somebody may argue, can we use rule number 2? No, you cannot use rule number 2. The reason you cannot use rule number 2 is, even at the same temperature, you can have both solid, liquid, or gas. Therefore, we cannot use rule number 2 to predict which one has the greatest entropy.